Welcome to the Canadian Tech Journey. Okay, perfect. So in this one, let's start talking about antenna concepts. It's not something that we don't know about so far or we haven't spoken about, but in this one, we're going to look into a little more details of antennas. So let's get going. So first of all, what is an antenna, right? Let's start by answering that. So again, antenna, simply said, is a device that sends and receives radio signals. Another thing I want you to remember, as I had mentioned in the last episode as well, is antenna receives and transmits the electromagnetic wave equally, which means while receiving or while sending. Both ways it's going to be helpful in receiving or sending the data, right, through RF. Reciprocal is basically what we want to understand here, okay? Radiation patterns simply are the places where the antenna is focused more on. Some antennas can be focusing their energy around them, trying to give passive gain equally, like an isotropic antenna, which is mostly Omni, which is mostly what we see in our indoor Wi-Fi access points. But you do have the use cases where we want to also try to have patch antennas, where I have a warehouse. I just need to shoot between the aisles where the people will be going and picking up their stuff. Whatever the inventory is in that specific warehouse. So that is a good use case for a directional antenna. Or another use case would be if you have a garden center which is outside a certain building, then they will put a patch antenna on that specific wall to focus onto that garden center. Or let's say if you're trying to aim something a little bit more far, or even looking for something like a point-to-point connection. So those are the kind of things where we're looking at different radiation patterns, right? Depending on where we want the coverage to be, based on that is where we're going to pick up our antennas. And then they have something called as polar charts or radiation patterns. Now there are two ways of looking at it. We have to look at from the top view, as they call it, or from the side view, right? Now depending on how the antenna is, they might be different. They don't have to be same all the time, and that's why we need to start to understand that where is my antenna focusing on. And again, if you look at some of those representations of the polar charts, you'll see those rings. The outer rings represent the strongest signal. They are in dB. They are using a logarithmic scales and not a linear scale. We'll talk about that in a bit. So this is how a typical radiation pattern looks like. Now this is an indoor AP, as you see. In this one, you would notice that this particular AP, if I'm looking from the bottom up to my antenna, it looks like a circle, I would say. But if I'm looking from the side, it's not really a perfect, because it's more a highly directional Omni antenna, where it's more like a donut, I would say, or a bagel, whatever you like to call it. They are going to be separate for 2.4 and 5, because each antenna would be, giving a different output depending on which frequency you're working on. Looking at polar charts is also something very interesting. So logarithmic scales pretty much works with the ratios. So difference between a 0 and a 10 would be same as 10 and 100, which really means is both are 10 times of each other. Where I'm looking at a linear scale, which is more like a graph paper. When we were kids, we all used it. Difference between 0 and 1 or a 10 and a 11 would be same again. And just because we're trying to represent it times the power is, it's much easier to work with the logarithmic scales. That's why in the polar charts or the radiation pattern diagram that you see, you will always look at these as not linear but logarithmic. And that is also the reason is why, because if I'm using a logarithmic scale, it's much usable in terms of way it's increasing. So again, it's going a little bit from 0 to 3 to 6 and 15, wherever if I try to look at the linear, it is going much bigger, and it's harder to work with such a big numbers. And same was true when we were trying to look at why did we use a logarithmic scale when we were trying to measure signal, is because the drop that I see was a lot. So I can't say 0.000008. It's much easier to say minus 70 or minus 80 dB, which was much easier to work with from a number perspective. And if I'm looking at these charts now, you have to understand that the reason is now when we're trying to say, okay, what does azimuth or top-down view looks like versus elevation cut? It's like I'm looking at the side versus I'm looking at from the top. Now let me show you a very interesting way of looking at these things. So let's say if I have a radiation pattern that you see right in front of you. If I'm going to look it from a 3D perspective now, this is how it's going to show up. If I'm looking from a top view, it's more like a circle kind of thing. But if I start looking at the same thing from a perspective of being, show me this, how does it look like from a side perspective, right? So it is much different. This is the elevation. So elevation would look more like a 8, and then if you're looking at the top, it's more close to a circle. Both of them are not the same. So hopefully you're getting the idea that when you start to look at 3D, it's much different. This is the top view or the azimuth, and this is your side view or the elevation. That's the best way to look at it, 3D way. Now, if you're using the Hamina tool for designing, they have done a fantastic job there. So let me bring up my Hamina tool here. If I have a floor plan right here, and if I want to start looking at how my antenna's gonna look like, so if I, let's say, pick up an AP in this case, right? So if I'm picking up this specific AP, in this case, I've picked up an Aruba 514, which is an external antenna AP, which takes an external antenna. So what I can do is I can use different antennas. So as you hover over these antennas, they give you the same nice looking 3D view. So shows you that I have different patterns. What is your use case? Are you trying to shoot far, trying to go more wide? Then I'm gonna look at something like this. But if I wanna go and look more far off, then maybe I'm looking for something more thinner, right? This is gonna go much more farther. Hopefully you get the idea that depending on what antenna I'm gonna try and use, see, different antennas give you a very, very different. To remember is the bandwidth of that specific antenna, right? What is a bandwidth? Bandwidth is like, where is the strength of that? Where is the main lobe of that specific antenna? And again, you're kind of measuring between the strongest point. Now, the best way to do that is look at this. So if you have this, the outer ring is the strongest, minus 3 dB is kind of here. So you plot that this is minus 3 dB, this is minus 3 dB. You draw a straight line back there and try to see what the degree is. So whatever this degree is, that is the degree for this specific antenna, when it's going to tell you that what is my beam width, which is in degrees. Another way of looking at this is something like this, a little more easier to look. Again, it's much easier to see this way. Again, if you look at the green ring, it tells you this is the cross point where it's at 3 dB. You take the pink line, drop it all the way down 80 degrees. So beam width for this particular antenna that you're going to work with is going to be 80 degrees. As I mentioned to you when we started the topic, there are different kind of antennas depending on if it's an Omni, which is going to be 360, you have a patch between 30 to 180, different use cases. And again, if you're using a Yagi sector or a parabolic dish, depending on if you're going to try to do a point to point, trying to join two buildings. Okay, to quickly just look at the main antenna types here. So omnidirectional is going to be the most common one that you'll see out in the field, right? If you're looking at most of the indoor deployments, any indoor buildings, schools, offices, mostly are going to be omnidirectionals. It's just because it's cheaper to get Omni, because it does not have any external antennas to it. So they do have in-window antennas which are Omni, so much easier. Aesthetic wise, again, easy to manage because they look much nicer as compared to if you're looking at some of the counterparts which are external. They don't look as nice, I would say. Semi-directional again boils down to your use case, where you're trying to focus your energy in a certain area where it's maybe a 180 instead of going 360 around. Some of the examples I gave you, garden centers, aisles between the warehouses, those are pretty much the good use cases for semi-directional. Highly directional will be when you're trying to really go point to point. We're trying to connect two buildings or highly directional antennas. Some use cases that I saw in my experience was when I was working at a rail yard where they were trying to put cameras on those poles. It was hard to give cabling everywhere, so they said, why not just mount the AP, because we have power, have one AP talk back to the other AP, the root AP, and then have the camera connect on the Ethernet port, and that way we can capture the video. So some very good use cases everywhere, depending on again where you're playing here. Omni, the best way to example is to look at light bulb. As I go into a room, I turn on, the light goes everywhere. The whole room is lit up at this point. That's the easiest way to imagine this. If I'm looking at patch antenna, which is again focused more in a certain area, your flashlight there, and highly directional, maybe the laser beam. That's probably another good way of looking at it, right? Only thing I want you to remember is this is why the mounting becomes very important, and we'll talk in the next episode on the mounting aspect of it and why it is important. Now for now, this one, I hope that everybody understands that what are some of the different kind of antennas we have, and how do I read their polar charts or radiation patterns, and I'm able to imagine them from a top-down view or on the side view. Again, I tried to show you some 3D examples just because once it's visual, it's much more easier to understand that way. From a specification standpoint is, what is my gain in dBi? And it could be different or it could be same depending on which frequency I'm using, 2.4 and 5. Beam width could be different. If you look in here, beam width on 65 degrees on 2.4 versus a 55 on 5 gigahertz. I'm using the same antenna, but it's a little bit different. Make sure that you're understanding that. The biggest gotcha are your antenna connectors. These are specific. Make sure that your connectors are matching with what antenna you're going to be using and your AP. There are a whole bunch of them, so please make sure that that is something that you're going to be considering, right? And then obviously which mounting option am I going to using, a pole mount, wall mount. Hopefully that was helpful, and we'll see you on the next one. And that concludes another insightful journey through the world of technology with Canadian Tech Journey. I hope you've gained valuable insights and a deeper understanding. Remember, the learning doesn't stop here. Keep exploring, keep cautioning, and keep learning. Feel free to subscribe to the channel for more exciting content and updates. Thanks for joining me on the Canadian Tech Journey. Until next time, keep learning and stay curious. See you in the next adventure.